How about it? Yeah, hello.
Hello.
Happy day after a 3-day weekend. Anybody do anything fun? No, nothing to speak of? Fair enough. We had an easy weekend at home. We took my son bowling yesterday. Like to send a shout out to the bowling alley south of town. Have you guys been there? Colonial Lanes. It's awesome. It's like 1985 called, and like the Brunswick bowling alley of my youth is right there. So it's like an old school, like nothing fancy. You know, you can still kind of like smell the cigarettes. Like, you know, it's like it's old, but it's wonderful. And they have real skee ball. Shoe rentals are $2, and you can bowl for $5. Like, yeah, I know. It's crazy. Cash only, but highly recommend. They have happy hour from 3 to 5. They have student discounts one night a week. So if you're looking for mixer opportunities for your cohorts or whatnot, bowling. Bowling for the win. But now it's Tuesday, and we're back talking about, you know, populations and samples and fun stuff like that. I did want to point out, so your task for this week was to try out the homework system. How's that going, folks? That's good? Good. So the only questions that I've had have been about the end. So once you finish filling this out, I have one open here. You check and save your answers. You can exit out and come back, and whatever work you have will be saved. Once you hit submit final answers, you are not done. That's the one catch that people forget, because I want to make it so that people don't submit accidentally. Zoomers, I need a screen share, don't I? I'm demonstrating the homework system. And by the way, Zoomers, if my audio cuts out or I forget to screen share or something, please let me know. I'm not doing it on purpose, I promise. So it looks like after you do that, two things are going to happen. One is that all of your answer boxes go away, so you can just like read through your paragraph without distraction. That way you can decide whether you're happy with your answers. And the second is that you're not done yet, because it wants you to re-enter your 8-digit ID number. I do that on purpose so that you don't submit accidentally. So to submit for real, you will enter your ID. I think, let's see, who is this? 1, 2, 3, 4, 5, 6, 7, 8. I think it's person 1. We'll find out. And you'll know you're successful if it says at the bottom, thank you, your answers have been submitted, and you can log in to see your score after this date. And then when you go back to the main page, rather than it saying begin or continue, it will say view submitted answers. And it will stay in this sort of amorphous black spot in terms of the answers for the drop-down menus. So like these will just all be like that until it is time for after the assignment closes. Then once it closes, meaning that you have a due date, then anything wrong will be in red and right answers will be in green. So if you haven't had a chance to play with that already, please try to do so within the next day or two, because I'd like to release homework 1 pretty soon. Your thing to work on between now and then will be your first formative assessment. I have not opened that yet because I wanted to see how far we were going to get today. But the idea is that after class, sometime between after class Thursday and Monday night, you would answer the questions, and that is inside Icon. So under quizzes in Icon. One of the questions I will tell you now deserves a little bit of explanation. It is every first formative assessment of every class I ask this question. The question will be, what is your theme song? So picture yourself entering some like sports arena, right? You come into the field or the game and there's a song playing on the loudspeaker for you. What is that song? That's what I would like to know. So if you're willing to play along, I will ask you to put a link to it on YouTube. I will build a class playlist and we can listen to each other's theme songs. It's anonymous, so whatever language, I don't care about profanity. Anything that motivates you, like it's fine. Obviously, I don't care about profanity. I would say there are no wrong answers, but someone once told me that Christmas music was their theme song, and I'm like, I'm sorry, that's incorrect. That's just incorrect. No one ever walked out to Silent Night, you know, to go like win the game. It's not going to work. Beyond that, though, like something that motivates you in particular. I tend to listen to older music, like the music of my parents in 70s and 80s, maybe 90s, and so there's not a lot of new stuff that I've heard. So if there's something that you think is like a banger and you want me to be familiar with it, you know, send it to me, all right? So that'll be on your last question of your formative assessment. I will let you know once that is ready, probably tomorrow morning, once I get everything configured. All right. any questions or things I'm forgetting? No. Okay. Then I'm going to pause the recording for right now. Unpause. There we go. Now we're back in business. Reshare the screen. So regarding attendance, I know I have two official sections, Zoom and not Zoom, but I don't care. Like, just come whichever way it makes sense for you to come on a given day. I don't need to weigh in on that. If you are sick, staying home is a great idea. If you need to do other things and it's more convenient for you to Zoom in instead of show up, that's fine with me too. So it's all good. All right, then should we pick up where we left off maybe? And if you have questions, can you remind me of your name when you start talking? Because I'm going to work on learning them all, but it's going to take me some time since everybody's brand new. But thanks for playing along. And in doing this, I'm going to have to introduce you to a few more of my unfortunate expressions as well. So we talked about notation at the end of it. I looked at all the letters on my slide and went, ah! So I'm not going to worry too much about Greek versus Roman notation. What you're going to see is kind of a hodgepodge of the two, but I do want to present just what are the ways in which the summary statistics that we talked about last time would be computed. So we had two different main categorizations in variables, right? Numbers and not numbers. Like, those are the main kinds. So not numbers, categorical variables, class variables, discrete variables, grouping variables, things where the numbers might stand for labels, but they're not meant to be sequential or otherwise convey numeric information, and then numbers as the alternative. So there were three things we cared about in terms of describing a number kind of variable, where the middle is, how spread out it is, and how lopsided it is. Those things known more as central tendency, dispersion, and skewness. So we talked about that. We showed some pictures so we can get into notation. So I want to show you notation to get you used to seeing it. But I want to reiterate, we are not computing anything manually, all right? I promise. I will show you how to make the computer be a calculator if you need to do math on something. Question?
Did you hit record before you started up again?
I did.
Okay.
Thank you for asking, though. Because, oh yeah, that does happen sometimes. I forget to hit record, or I forget to put it off pause. And I promise you that if I do that, I will sit in my basement and re-lecture what I did. I've had to do that before because I'm making a promise that you guys will have recordings to come back to, and so I want it to be a complete set of everything. So yes, thank you for the prompt. All right, some new language. So in describing quantitative or binary variables, we can compute a mean with this formula. So this thing right here, you're going to hear me call that y sub I. Y is going to be an outcome that we are predicting, the thing we want to understand. Why are some people higher on this variable than others? Let's figure that out. The I is a subscript. That means that this is a variable that varies over people or individuals, as I is my index for that. Big N, capital N, stands for the number of people in the sample. You will see this reported in method sections and in your first homework, which is essentially to complete a method section. Y sub big N is the last person in the sample, and Y bar is the arithmetic mean for your sample. So it does not have an I subscript because it is a constant, it is not a variable. Things that have subscripts are variables, things that don't are constants is a general operating principle. So computing a sample mean would look like this in notation: add up all the scores, then divide by the number of scores that you just added. So here's the English translation as to what this looks. This thing is a capital letter sigma. It means add them up, add them up, up. Sample mean is an estimator of the population mean. We would generally call that mu. We don't ever know what the population is, though. That's the thing. It's like this hypothetical construct that we're talking about. Variance, then, is the next thing. How spread out the distribution is. So that takes the mean as one of its components. So to compute variance, it's your score for each person minus the sample mean, square that. Do you know why we would square it? Positives and negatives cancel otherwise, so squaring fixes that. Then we sum over all the people. So starting at the first person, I equals 1, and going up to big N, We sum the squared terms here, the squared deviations as they are called, and we divide by n minus 1 if we're talking about our sample. So y minus 1, because of y bar here, in order to compute variance, we had to compute the mean first. So it's like we spent some of the available information in our data to compute a mean by which to get the variance. And you will see S squared in textbooks that describes sample variance. You will also see this thing. This is sigma, that little circle looking thing with a hat on it. I need to take this E off here, that hasn't been introduced yet, but later on you will see this as sigma squared E in our models, the idea of variability. So variance is a weird thing because it doesn't have like an intuition to it. Like if I told you our variance is 100, you'd be like, is that a lot? So to make it more intuitive, to describe the expected spread around a mean, we would take the square, and here's another expression for you, square root. And you're like, what the hell is that? Square root if you are not from the Midwest. But if you are from the Midwest, square root sounds completely fine. Like I go up to my root, I drink root beer, and I take the square root. Like that's just how we roll. Square root for the rest of you. Square root of variance is something called standard deviation. SD for short. It's how far off from the mean each person is expected to be on average. Average offness. So I take my variance of 100, I take the square root, that turns me into a standard deviation of 10. So I can say on average, people are off from the mean by about 10. That gives me a more intuitive sense as to how spread out people should be in the metric of the variable that we're familiar with. Okay, with me so far? All right, skewness, how far off you are from the mean cubed to the third power is how we get skewness. So this is how lopsided your distribution is. Oh, no, I thought I had something coming over here. So if you have a positive skewness, that means there's more people pulling the distribution away from the left towards the right, like the positive side. And that means the mean is going to be higher than the median. The mean is going to be pulled towards the direction that the tail is in. Mean, median, mode are going to be right on top of each other if it's a symmetric distribution. And then the opposite will happen if the tail is towards the negative side. The mean is going to be pulled down and the median is going to be higher. So if you don't know what shape your distribution is, looking at the differences between these numbers can give you a sense of that. So putting this into the picture that we showed last time, this is average income in $1,000 units from the General Social Survey from 2014, I think, something like that. For your first 4 examples, I'm using this data set because it has things in it that, regardless of what field you're from, are understandable. So we'll be looking at income, money. We all know what money is, right? We'd all like more of it, if possible. That may be part of the reason why you're here, is career opportunities. Education, years of education may be related to money, may not be, we'll find out. And a few other variables in the data set that are fairly universal types of things. That's why I picked it. So in this particular data set, is this positively skewed or negatively skewed in terms of this distribution?
Positive.
Positive, yes, and feel free to read from the screen. The answer is usually up there somewhere. I am shameless when it comes to course participation. I want everybody talking with me. So the mean itself is 17.31. That means the average person in this sample made about $17,310. So it's older data, not a particularly well-off sample. The median, though, is only 13. So the rich people out here are pulling the mean towards them, and the median is staying in the middle. So the median, by definition, is the 50th percentile. It's the middlest number, or interpolated across the middle too if it's an even number. And then mode is the most frequent one, which happens to be 22.05. So this is an example of a continue-ish variable. They clearly asked these questions in terms of ranges. Like, what do you make? 500 to 1,000, 1,000 to 1,500. Like, they bend it in some way. Otherwise, you would not see a mode that is that specific. Variance is 190. It's like, well, I know that this is income, but what does that tell me? Standard deviation, square root, is about 13.8. So the average person deviates from this median of 13 by 13. So this distribution is lopsided because you can't go past 0 in income. Interquartile range is something else you may see. Usually that is paired with the presentation of the median. So it's the distance between the 75th percentile and the 25th percentile. In this case, that would be about 15. So median and interquartile range are things you would report for data that are lopsided like this, that are skewed, or where you have extreme cases that you're worried about biasing the mean and the standard deviation more towards them. Like it's not a representative number, and that's what you're concerned about. All right. Here's another kind of picture you may see. I don't see a whole lot of these anymore, but they're popular in intro stat, so I thought I'd throw one in. It's called a box plot because it's a box. There's cooler versions of this called violin plots that you can look for nowadays. They're more colorful and differently shaped. But this conveys all of that distributional information. So the line in the middle is denoting the median. The point right here is the mean, minimum, and then these are considered outliers, which is a term that just means too far away from what's expected based on that distribution. It's going to have a more specific definition later on, but people just call these sort of outliers in terms of their extreme cases. One more, kurtosis. Like, what the hell is that? I still don't know, and I teach this stuff. Kurtosis is how squished it is. Which you're like, didn't you call variance that 2 minutes ago? Yeah, I did. Kurtosis and variance are very difficult to tell apart visually. So know that you've seen this, and you can ignore it for the rest of your lives, okay? Done? If you ever hear the words moments of a distribution, that's a statty term. Does that sound familiar? Like in the normal distribution, the first moment is the mean, the second is the variance or standard deviation. The third, see, look at the 3 there. The third is skewness. Can you guess what the fourth is? Kurtosis. In the normal distribution, skewness is supposed to be 0 and kurtosis is supposed to be 3. So that's where the -3 comes in. We don't normally worry about this because there's nothing like to be done to fix it. Like it's just how peaked it is. So let's make our computer give us this information. Yes. This is your first homework. You're going to get a chance to practice this. And again, I know you all know what a mean is. How is that, y'all? I know all y'all know what a mean is. That's not the reason we're doing this. The reason is so you get used to the software. Okay, that is what the learning opportunity is here, particularly if you have to navigate getting into the University of Iowa virtual desktop. There's some steps that it takes, and I have handouts for that. If you're installing R for the first time, there may be a little bit of a learning curve doing that as well. But this is Stata code. There is a command in Stata called summarize, and it does exactly what you would think it does. It's for quantitative variables. In this case, the name of the column I want it to summarize is called income. Commas are used to differentiate options, so extra pieces of information you want to show up with the bare default printing. And detail means give me everything. So this // in green, this is a comment. This is a note that you can leave to yourself about what your code does or why, and the computer will disregard it. Universally in software, comments are colored green. Like someone just decided that and every other programmer just went with that. So when you see green, think that's a note. So here is the result. This is what would show up in the Stata output window. It gives you percentiles. It gives you the mean. It gives you standard deviation. It gives you variance. It gives you skewness and kurtosis. So this is positively skewed as indicated by the value of skewness that is positive. Can you guess what number negative skewness would be? A negative number. Yeah, it works just as you think it would be. And if you're like, that's a lot of numbers, can you just give me something simpler? Sure. If you take off detail, this is what you get instead. Just bare bones. Obs? What letter goes with obs? Vocabulary drill.
Observations.
Yeah, number of observations. What letter are we using for that? Big N. Yep. And these ones, we'll see later on what they become. Here's what it looks like in R to get something that is equally comprehensive. This is not a base R thing. I am using a particular package that a psychologist made. He named it Psych, apropos, and it's called Describe. So going from the inside out, this X right here means what would you like me to summarize? Example 1, $income. Example 1 is the name of the data set. In R, you can have multiple data sets open at the same time, so you have to be more specific. $ actually has nothing to do with the fact that this example is income. That's an unfortunate coincidence I'm looking at for the first time. $ just means, okay, what variable inside my data set are you talking about? Income is the name of the column. And in both of these programs, it's case sensitive. So it needs to match whatever is stored in your data set. So this is the column that I would like described. Quantiles, that's asking for the 25th percentile, the 50th percentile, and the 75th percentile. The 50th percentile has another special name. What is it? That's the median. Cough, cough, homework question. IQR equals true means I'd like the interquartile range, please. If you don't want it, can you guess what you would type here instead? False. And what if you don't like typing capital letters? And yeah, it'll be like, what are you talking about? I don't know what true means in lowercase. You got to pay attention. So I did all of this inside here, and I fed it to describe, and it didn't give me enough digits after the decimal to make me happy. In the homework system, I will tell you how many digits to report. If you need to report more, then I wrapped the inside of this into a print function. So the first thing is, what do I want to print? All of that, and I'd like it to use 4 digits instead. So that's why we get 4 digits for these outputs right here. So you can get whatever level of precision. And it gives you a lot of things. Lowercase n, just because, R needs to be difficult. Mean, median, standard deviation, some kind of trim mean, bunch of other stuff. The one thing that's not here is variance. Because the guy who made the package didn't want to put it in there. That's the only reason. Like, you're going to come across these sort of arbitrary decisions by coders about what's included. So if you want variance, you can just ask for it. VAR is a base R function. You put inside the parentheses what you want the variance of, and it will spit it out to you. So then I get the 190 back. Likewise, if you just want one number, you just want the mean, or you just want the standard deviation, you can use functions to ask for that. And a semicolon, by the way, allows you to put multiple commands on the same line and not have to return after each one if you want your code to take up less space. So I do that periodically for things that are sort of the same idea in terms of what I'm asking for. Ignore the 1 inside the brackets. That just shows up on your output, okay? Ignore it. Same thing with these 1s over here on the left-hand column, ignore them. All right, how we doing?
Question.
Yes.
So if you wanted, say, the 10th percentile with R, you put in 0.1 in your list?
Yep. And there's probably a function that will spit them all out if you want to, if you dig deep enough into the bowels of R and all the choices. So these are just sort of examples of how you can do things. And to remind you, what I'm expecting of you to do in your homework is to take a sentence like this and figure out what needs to be changed to make it work for your data. Okay? That's your job. So if I asked for, homework 1 as a data set, if you've named it something else, you'd change that here. You'd change the name of whatever the variable is and potentially a different quantile if you wanted to ask for something else. Binary variables. You can compute means for those too. The mean is called something else. It's called a proportion, or the proportion. So in looking up things about binary variables, you'll see this proportion. It is the proportion of people who have a 1. That's the mean. It's fine because there's only one difference. It makes sense to talk about the proportion of 1s because the rest of them have to have a 0. Like that's all there is that's possible. But for nominal variables, so nominal is a categorical variable with 3 or more categories that is unordered. The numbers are not numbers. So this is marital status, where 1 is married, 2 is widowed, 3 is divorced, 4 is separated, and 5 is never married. I can ask R or Stata or SPSS or any package to give me the mean of this variable, and I did that. It's 2.74. Does that tell me anything? No, not a thing. And the software is quite happy to give it to you. So this is where the interaction of using technology, but doing so in a logical and responsible way. Like the people still are the ones who have to make sure that that happens. Because 2 and 3 and 4 and 5 are not numbers. Now what about this one? I have a 5-category ordinal rating of how happy people are, from unhappy as 1, 2 is neither, 3 is fairly, 4 is very, and 5 is completely. The mean of this variable is 3.56. Are you okay with that? This is a tricky one. You'll see this all the time.
Depends on what you use it for.
Yeah, but...
I mean, I would say I'm okay that on average people are fairly okay, but I wouldn't go beyond that.
Yeah, like you can say the average person is somewhere between fairly and very happy. But are these really numbers? They're not. Like I could make up labels of -12, 37, 402, and 70,000 and 8 million. Those are equally ordinal, but then I would come up with a very different answer as to what the mean would mean. So the question that you would have to ask yourself, I think, in thinking of this as a predictor, is eventually we're going to talk about what happens to an outcome for a 1-unit change in a predictor. As you go from 1 to 2, what happens? As you go from 2 to 3, what happens? As you go from 3 to 4. Treating this as a number implies that each of those jumps means the same thing. That the difference between unhappy and neither is the same amount as the difference between neither and fairly. Then when you put it that way, it sounds sort of weird. So I will teach you how to decide empirically whether it makes sense to think of this as a number, which implies fitting a line through the numbers and saying that each jump is the same size along that line, or to give each transition a different jump and letting them be whatever they need to be. It's an empirical question. If this is to be an outcome, this is not going to make a very good outcome. The outcomes in our model are supposed to be at least continue-ish. That's a word I made up. That's not a Midwestern thing, that's just a Lisa thing. But is this a continuous variable? Does the model understand that we can't predict a 0 or a 6 or a 7? Yeah, we'd have to make it understand that. And if you want to do that, that's my spring class, Generalized Linear Models. We're going to learn how to predict other things that are not continuous using the same machinery that you'll start this semester. Binary variables, you don't need to keep going in terms of what you would report about their variance, their skewness, or their kurtosis. All of those things are determined by the mean. In binary data, the variance is computed as the mean, the proportion of 1s, times the proportion of 0s. So if I have a variable that has a 50-50 split, its variance has to be 0.25. And note what happens to the variance as you move away from 0.5 in either direction. It shrinks. It has to. Down to the endpoints. If I have a mean of exactly 0, is this a variable? It's a constant if I have a mean of exactly 0. The only way that could happen is every single person had a 0. And that means there is no variance. Likewise, if I have a mean of exactly 1, that is not a variable. That is a constant with no variance. That is the definition of a constant, no variance. Believe it or not, there is actually a statistical distribution for this case right here. It's called degenerate. I learned that. That is the distribution I want for your grades at the end of this semester. I want you all to have a degenerate distribution. And that sounds like an insult when you say it that way, but it just means everybody gets an A. That's what I want. No variance, a constant, and even an A+. I do give out A+. I learned that A+ bump your GPA up past 4. So A+ give you a little bit of insurance in case things go sideways later on. I'm happy to give them out. Earn a 97 or above. That's how I'll give you an A+. Happy to do so. All right, so wrapping things up then. This unit is introducing us to vocabulary and software by which to get univariate descriptive statistics. Univariate means what? One, yeah. One variate, variable, meaning one column at a time is what we're focusing on summarizing. If we have a quantitative variable, meaning the numbers are actually numbers, we'd want to know some kind of minimum, maximum, mean, and standard deviation, or square that and make variance. If it's lopsided, if it has skewness to it, we might add median for central tendency, the middlest number, interquartile range for how spread out it is, distance between the 75th and 25th percentiles. And you can do data description using lots of different kinds of plots. A histogram, where you're binning the values together. Box plots or violin plots, those are things you can look up. But if you have a column where the numbers are just labels, then that stuff doesn't necessarily make sense. For binary, you can still compute a mean, but there's no point in computing a variance or anything else because it's determined by the mean. For nominal, means do not make any kind of sense. Neither do variances, because they're not numbers at all. For ordinal, it's kind of squishy. That's another expression. Squishy is my word for uncomfortable. Like, it makes me feel squishy when I step on crumbs in my kitchen with bare feet. Right? Or you step on like a bath mat that's covered in someone else's hair and it sticks to you. That face. Squishy. So
my kid's house.
my son gets really mad that my hair shows up in my bathroom when he wants to go borrow my bathtub to take a bath. And it's like, look, pal, who pays the mortgage? I'll put my hair wherever I want, thank you. Plus, I'm a hairball. I have a lot of hair and it goes away, so. Anywho, ordinal is sort of an interesting case because some people will treat them as numbers and some people would say that's not. But I think it boils down to how you use it. So, what is your intent? And in these categories, bar graphs are all you need. So showing the relative frequency or proportion in each case is enough information for your reader to follow what is happening in your data. All right, that's it for that one. For that one, yeah. Don't clap it out yet, or it's too early in the semester for that. But what I am going to do